Now, here's the circuit, and again, this is rather sloppy. And if you want a better version, look up Horowitz and Hill build a chaotic attractor, and they have the same schematic. It's a duplicate of what they did. But how it works is you have the multipliers, and then you have the summing integrators. 3 summing integrators, 4 op amps total, 2 multipliers, 8633s, which automatically scale it by 1/100th, so it stays within the range. And if you do this, it turns out because you're multiplying by 10 here, the first integral for x, you would use a 100K because we're normalizing with 1 meg. With this equation would be 1, the way we're normalizing this. So if we divide by 1/10 the amount, we're multiplying by 10, obviously. So these would be 200Ks for the first one. And again, you would take x from itself, and you could take y from the y input, which is actually doing negative y. This is x, and that's actually z. And it works out pretty nicely. On this one here, so you see we have minus y, xz, rz. The xz term is given by this multiplier. This is the symbol for a multiplier. These are operational amplifiers, and the use of the name operational amplifier comes from what we're doing right now, making them work mathematical operations. Now, this is fed across the 10K because you're dividing by 100 and you're multiplying by 100 due to the normalization scheme I showed earlier. And this one, 35.4 kilo ohms from the X input, is this term, the RX, and that's 28. So this is an odd value resistor. I have to use a potentiometer just to trim that value to make an equivalent resistance because I didn't have an off-the-shelf part of that make. And so we have the Y term. And note the inverting amplifier here because this is negative Y, and you want to subtract Y, and you can't do that without, this just inverts the sign. It's unity gain. These would be equal in practice. The final term, this equation, B is going to be 8/3 plus XY. And so when you take negative y and x, that's going to equal negative xy, and this thing would invert the sign again. Again, 10K because we're multiplying by 100 of this voltage, which is divided by 100. Again, it's doing that to try to prevent it from going out of the range. And this is 354, I think, kilo ohms, or thereabouts. Again, this was done with a trimming resistor because you can't buy this value. So you have 3 integrators, 2 multipliers, and again, you could build these as an operational amplifier circuit. And what the idea is behind it is you would build a circuit which could take a logarithm of 2 different numbers, natural log of x and y, and then you would use a summing amplifier similar to these integrators, only a summing amplifier would have a resistor here and not a capacitor. These are summing integrators, as I mentioned earlier, which I showed on this diagram here with their characteristic equation. This is just basic 2040 material. What you would do is it would take the log of both, it would sum them together to get log x plus log y, and then it would take an antilog. And then the output would be proportional to a constant multiplied by, again, x, y, based on log rules. The problem is, this is actually very hard to make as a circuit. I actually did this, and if you want to watch a separate video, I can show how this works. But when you have like this Lorenz equation, a AC voltage, the log circuit is roughly, well, it's a diode across an op amp like this. And the problem is it can only do half a cycle of this AC, of this AC waveform. And to make it work in 4 quadrants is actually difficult, and I only recently made one of them work, and it costs 4 times as much as the chip. So just go with the 8633, what Professor Lanternman told me. So we have our circuit here. Again, this is messy because it was drawn on the spot, but you can look it up on Horowitz and Hill. They're professors at Harvard. And the conclusion is the same. So now all that's left is to build and test the circuit, and we can see the trajectory, again, by taking these into an oscilloscope on XY mode in real time. And That is the ultimate culmination of this project.